Hey, Benji here. Welcome to SimCity Guide to Custom Creations. In the first video I provided an overview of how these funky SimCity materials work. Now I'd like to follow up with some more detail about the textures contained within material sets. I mentioned before that Oppie has created a tool for 3ds Max that can apply SimCity materials sets to custom models. Unfortunately, we currently have to use the material sets that already exist in the game, but my goal is to eventually make our own, and it's certainly possible. I know that these material sets will be essential to a custom building pipeline, and in my opinion they're a huge part of setting our buildings apart from the buildings in the rest of the game. So I want to share with you what I know about the textures, and I think you'll find that when I'm done you might be able to start designing and creating your own. So material sets are made up of 3 images: a color map, a normal map, and a shader map. Now here's what's interesting. The RGBA channels of each material set image are used separately to store each texture, and SimCity stores a total of 6 textures in the RGBA channels of the 3 images. Now I don't want you to get confused. The textures we're looking at are not from the same material set I've been showing. If they were, you would see the brick element that we've looked at and the same windows along the bottom. So as you might already know, a digital image is most often a combination of the red, green, and blue channels, and depending on the format, an alpha channel. If you look at an image from a material set, however, the RGBA channels are not used to form a coherent image when combined. In fact, in this case, the RGBA channels aren't meant to be combined. Rather, they are used separately to store textures used by the game engine to render materials. My best guess is that, like everything else we've seen, this is for efficiency and to save space. By using the individual channels to store information, you're getting a kind of free Photoshop type of file where you can open it up and there's multiple layers inside, but the file is a lot smaller. You don't need the file to store the color information that will be displayed in game, and that also consumes the RGB channels, because the color is applied by the color palette later. So, when you extract all the textures from the channels of each image of the material set, you get a total of 6 textures, which you see here. And don't forget that every one of these textures is a collection of textures, because a material set is a collection of materials for all the elements that make up a particular building style. Now at this point, having sort of opened up and spread out the contents of the material set, imagine that the rendering engine crops out portions it needs from each of these textures to apply a single material to the layers of a section of your model. So I want you to imagine this cropping out of a portion, because that is what you will be doing with the 3ds Max tool when we get around to it, when you assign materials to your buildings. Let's take a look at what's inside the first of the 3 images of a material set, the color control map. Now this one's pretty simple because the RGB channels in the color control map control the tinting of the material. So there's 3 out of your 4 channels gone right there. So the RGB controls the tint. Basically this is 3 entries into the color palette. In other words, 3 different colors that can be assigned to the material. So take a look at one of the window elements along the bottom. Each of these color control textures have a red, green, and blue color assigned, and each colored area of each of these color control textures can be assigned a different color from the color palette. So you can think of the colors in the color control map as placeholders for colors from the color palette. And the alpha channel of the color control map controls 2 things. For the base layer, it would define the alpha channel or transparency of the base layer, and for the top layer it would define how much the layer is blended in with the base layer. The second image of our SimCity material set is the normal map. Now, like the color control map, the normal map uses up the red, green, and blue channels of its image. A normal map is used to define the bumpiness of a material and its reflection angles. Now, the alpha channel of the normal map stores the ambient occlusion of each material. If you don't know, ambient occlusion is a subtle but very important shadow effect that provides the contact shadows between the cracks and seams of the geometry of an element. Remember that each material in a material set doesn't actually have geometry, but the ambient occlusion is baked from the 3D version of the material. We'll see this later. So in other words, a 3D window frame was created and the ambient occlusion was rendered and baked out of that. Now you can't see the ambient occlusion layer in the normal map, but if you were to peek inside the alpha channel of the normal map image in Photoshop, it would be there. And you can see some examples of the ambient occlusion effect isolated in some screenshots from the game here. These images might also be a mix of the ambient occlusion and the game shadows effects, but you can still make out what is the AO and what isn't. You can actually see the ambient occlusion by itself whenever you enable the data maps in the game. It's pretty cool. So notice how much detail the ambient occlusion enhances in the texture on the side of the mobile trailer here. So you see the alterations in the dark stripes, that was rendered from an image where the stripes on the side of the trailer was actually metal, or modeled to be metal indentations, and the ambient occlusion effect was created within the, I guess you would say, the indentations of the cracks in the metal. So the game interpreted that as having some depth and I guess areas where contact shadows would be applied, and it rendered the shadows into there. And so when the ambient occlusion texture was rendered out, you get all that detail. It's a really cool effect. We've reached the final and probably the coolest image of the SimCity material set, the shader map. If your settings are cranked way down, I think these textures are one of the first things to be dropped by the rendering engine. The red and green channels of the shader map store the information required to render the relief mapping. This is an effect that Ryan Ingram talks about in his Building and Rendering SimCity blog post from May 2013 on the official SimCity blog. Unfortunately, this tool requires special tools to generate the relief map assets. If any of you have any graphics rendering related programming skills and want to try to tackle this, I can forward you some more details. The blue channel of the shader map controls the specularity of a material, and specularity is used to define a surface's shininess and highlight color. There's an example of a specular mask there. The alpha channel of the shader map defines the location of windows, specifically where the glass would be, so that this area can be displayed as transparent and you can see through to the interior maps on the inside. The black equals no interior, white equals full interior visibility. And here's a tip I got from one of the developers. It said that for the most part, the mask is either black or white, but you can get some interesting effects by setting it to, say, 80% white. If you use partial visibility, you will get surface that is, in the case of 80% white, 80% interior, and 20% whatever the surface would be, showing if there were no interior. This trick can be used to create a tinted glass look. I'm not sure where the information is that stores the reflection effect. I think it might be in one of the rows of the color palette, and how this works is I think if the game picks a color from a certain row of the color palette, that row is defined as kind of like an effect row. So a color picked from a row that defines reflection would tell SimCity that that color is assigning reflection, perhaps what shade of color that is defines what kind of reflection or how much reflection, or maybe the reflection is just related to the opacity of the window. But either way, I also think that other rows of a color palette might define whether or not a color of a material emits light. So I'm still looking into how these special effects work. So how are material sets made? My best guess comes from the image you see at the right here from a presentation from former developer Andrew Wilmot. It looks like each material object or element was built in 3D and arranged onto a plane, with this arrangement representing the final composition of the material set images. I'm guessing the camera was probably pointed directly at the square, probably with a parallel projection, since that would serve to create the flat perspective you see in the final material images. And sections of each object were probably assigned materials from the 3D app with 100% luminant color of red, green, or blue. And rendering that out as a straight color image would essentially give you the color control map. Now, these elements floating around the perimeter of the main square, I'm guessing, are waiting around to be arranged for their final, for lack of a better term, snapshot as a material set. Maybe this 3D designer received these elements from other artists, and so he was in charge of converting them into material map sets. You know, now that I consider this image and I've thought about it, the creation of the material sets seems fairly straightforward. It's mostly a lot of design work rather than technical know-how, at least until it comes time to package them up for the game. Then it's time for a tool from Oppie. So if you have the 3D skills required to make a model and make textures anyway, making these material sets doesn't seem like a big deal. So using this kind of idea of how I think the material sets are constructed, I tried a fast experiment where I built out some quick and dirty window frames, and then I rendered out a couple of passes. And here I rendered out what would be the color map, normal map, ambient occlusion, and alpha or window map. I didn't take time to do the specular map, and the depth map is still a little bit of a mystery, but the ambient occlusion would need to be packed up with the normal map into its alpha channel, which you could do in Photoshop. But then you would be left with your 3 images of your final material set. So really, I mean, what I think I've discovered is, as is the case probably with most creative projects, is that with these material sets, most of the time is spent on the design and creative process. And in the case of making all these elements, a lot of time would be consumed just creating them in 3D. When it comes time to render out your material sets, you just need to arrange them onto the palette like I've shown here and spit out your different render passes. So I'm going to step out on a limb and say that you can begin to create your materials for your material sets. Because before you render them out to material set images, you've got to design and model them. And here, since only snapshots of their textures are what is exported, you don't have any polygon constraints. So I think I'll try and think of some tips for designing a material set for an upcoming tutorial. But don't let that stop you from getting started. That's all I know about material sets. Next time I'll go into depth on the color palette. And after that, I think, like I said, I'll think of some tips for designing a material set. Maybe I'll start working on my own. So now that you can model your buildings and your material set objects, there's a few things you can work on. So get to it.